October 26, 2021. This is the Online Math Tutoring stream for MathCelebrity.com. Let's get it started. We're going to cover a bunch of problems that came in last night that the search engine didn't pick up. I'm going to automate some of these in the future. Some were automated, but I wanted to pull them out of the thread just so people can see how these problems are done that haven't used our site before or didn't know that our site could do this. So here's the first problem. X is a woman who served as U.S. president before 2000. If you look at all the U.S. presidents before 2000, none of them were women. So the answer to this is just the empty set. No women U.S. presidents before 2000. So we have the empty set. So we'll just highlight this here. There's another symbol too for empty set if you want to use it. I just do the parentheses. So we'll do empty set notation, and we are done. All right, next one. Pick out some of these here at random. We got a bunch of literal equations problems last night, so let's blaze through a few of those. We've got x divided by y plus 9 equals n for y. All right. First, subtract 9 from each side to isolate the y term. So we do this. Minus 9, minus 9. Cancel the 9s on the left side, and we get x over y equals n minus 9. All right, so we're a bit closer here. What we want to do, cross multiply, because y is in the denominator. We have x equals y times n minus 9. Then divide, because we can multiply the denominator of this side by this side for cross multiply. Divide each side by n minus 9. Got this. Got this. And then cancel the on the right side. And we get, I'm going to move the y over to the left because I like to list the variable first. This is our answer to the literal equation. That's that. All right, let's scroll through here, see what we got. Let's stay on the literal equation tip. Next problem. A divided by DC equals B for A. This is a quick one. We have A over DC equals B. You can cross multiply the DC by the B. We have A equals B DC. That's it. If you want, and sometimes the problem lists the variables in alphabetical order, you could also do that. BDC is the same as BCD by the commutative property of multiplication. Going to put literal equations in there, and that one's done. All right, here's another literal equation. We've got 15y plus 13 over c equals m for y. Subtract. I want to isolate the y term from each side to isolate the y term. I'm going to do this. Minus 13 over c, and then we got minus 13 over c. Cancel the 13 over c on the left side. And we get 15y equals this. Now divide each side by 15 to isolate y. I'm just going to do this. Divide by 15. You got to wrap this in parentheses now because we're dividing the entire side by 15. We get cancel the y or 15 on the left side. We get y equal to basically this. Put this in parentheses. The next one. A number T is no less than 30 and fewer than 40. This is a compound quality. Take it in 3 parts. Step 1. Fewer than 40 means less than, doesn't not include 40. Therefore, we have less than 40. Number T is less than 40. Step 2, no less than 30. No less 30 means greater than or equal to. Why? Because it's no less than 30, meaning it includes 30. 30 is the bottom. This means x is greater than or equal to 30. So big difference is less than, there was no equal, so there's no equal sign here, but no less than means including. Step 3, combine these two statements into one compound inequality. I've got 30, x is greater than or equal to 30 and less than 40. So when I combine, I'm sorry, t, I use x, the problem stated t. This is how we write both of those statements as a compound inequality. That's it. And for those of you that are new to the site or the stream, you could find all these problems in mathcelebrity.com/community. Mathcelebrity.com is our main site with the calculators, but for the extended word problems that we don't automate or can't automate, I put them in the community link. Oh, and if you are new here, welcome. Where are my manners? All right, moving on. This is a good one. I'm going to have to automate this one day, but I'm kind of glad it came through so we could walk through it. The midpoint between M and N. The midpoint is halfway between M and N. So we have M plus N divided by 2. That's your midpoint. That's it. So the key here, the midpoint is halfway between. I'm going to italicize that. And it's also an algebraic expression because we're using variables here. And I will get that automated so it can handle any variable if you type in the midpoint is halfway between, or the midpoint between A and B, for example. All right, next problem. Some students and parents get tripped up on this sometimes, the phrase split into. Whenever you see split into, whenever you see the phrase split into, think of divide or divided by. Sum, okay. The sum of x and 4 means we add 4 to x plus 4. All right. I'm gonna move this here so we can go in order. Because what's the old saying? Order is heaven's first law. I love that. So it's split into 5 parts. So we got to wrap x plus 4 in parentheses because we're dividing by the whole term, and we split it into divide by 5 equal parts. And I want you to know this was the key here. If you always think of split into as divided by, you'll crush these problems. That's that one done. All right. Weighted average. All right, let's do this. Get warmed up, and then we'll jump into the harder ones. I like to knock out the easy ones quick. If the blackout, it just should be begins. If people type this in, I'll correct the spelling. If the blackout begins at 5:20 p.m. and ended at 7:05 p.m., how long did the blackout last? All right. There are two ways you can do this problem. You can move forward an hour to 6:20, and then you can count from 6:20 to 7:05. Or if you're lazy like me, I like to see 7:05 is kind of close to 7:20. So add 2 hours and we get 7:20. Subtract 15 minutes and we get 7:05. 2 hours minus 15 minutes. I'm going to italicize these so you know what move I'm making. Equals 1 hour and 45 minutes. And if you don't want to do the shortcut way, that's fine. You could just go 5:20, 6:20 is an hour, and then 6:20 to 7 is an hour 40, and another 5 minutes is an hour 45, however you like to do it. I like to do round numbers on the hour and then go from there. All right. Let's go through here. Let's knock this one out since we're on the algebra kick. This is another algebraic expressions. N is tripled means we multiply n by 3. Decreased by 5 means we subtract 5 from 3n. 3n minus 5. And that, my friends, is our algebraic expression and our answer. All right. Next. Oh, yeah. This is for all you folks in basic math. And then we get some younger kids and parents that use this site as well. So this is for you. Jimmy has 5 apples and Beth has 8 apples. Let me fix that. How many apples do they have together? The word together means we add. Total apples equals Jimmy's apples plus Beth's apples. 5 plus 8, 15. That is our answer. Key to solving this problem was the word together, so you know you add. So I'm just going to do basic math addition. All right, there's another one in the bag. All right. Do some unit cost. We get these all the time. $3.50 per pound. You bought $18.25 worth of strawberries. I want you to know that sometimes the students and parents don't always type in the full question, but I've seen this so many times. I know what they want. The question asks for unit cost. Unit cost equals total cost divided by total quantity. I'll just do this here. 1825 divided by 350 divided by, I'm going off camera here real quick to just bang this through the calculator. All right. This means unit cost equals this, but we're going to round. So dollars and cents, 4 is not 5 or greater, which means we round down and we get this unit cost. Anytime you see these type of problems, this is the formula you always use. You'll be given some price for some quantity, and they're asking for how much is one of whatever they want. So 1 strawberry, 1 apple, 1 box, 1 lunch, and this is how you get that. All right. We'll do a percent change. In 6th grade, Veronica reads 45 books. In 7th grade, she reads 63 books. What is the percent change? Percent change equals new value minus old value, and I got to wrap this in parentheses, divided by old value times 100. Actually, let me put the 100% out front. This tells you instantly it is a percentage. All right. This is the formula for any percentage change that you're asked. If the value goes up, it's going to be a positive change. If the value drops, it's going to be a negative change. So I'm going off camera here to our percentage calculator. Just one moment. Percent change. All right, here we go. Percentage change from 45 to 63 is what we want. What I'm going to do here when I get back on your screen is I will paste the math in percentage change from 260 percent change. Nope. All right. For some reason, my screen's stalling. So let's just do it manually. That's fine. 63 minus 45 divided by 45. I'm going to do this. 63 minus 45 is 18 over 45. And then we're going to do 18 over 45 is 40%. Change equals this. 0.4. Percentage change equals 40%. And sometimes it'll list this, sometimes it'll do the plus sign, but the key here is there was a percentage increase change. There is a percentage increase. That's how you solve these problems. Okay. What do we got next? Let's do this one. How many $8 tickets can I get for $100? Tickets equal total money divided by price per ticket. Tickets equal 100 divided by 8. Tickets equal $12.50. I'm sorry, 12 and a half tickets. 12.5 tickets. Sometimes your class will ask you to give a whole number. You can't have a half ticket. If the problem asks for a whole number, this means you cannot have a partial ticket. So therefore, we round down to 12 tickets. I'll bold this too. So this is a simple quotient and we are done. All right. Let's see what we're going to do next here. About that one. I'll go back to that one. All right. Let's do sales tax because I know we're getting a lot of junior high and high schoolers needing help with tax and as well as financial literacy. That's a hot topic right now in the news. So let's cover that. There is a sales tax of $15 on an item that costs $153 before tax. A second item cost $81.60 before tax. What is the sales tax on the second item? We assume the goods are bought in the same store, so tax rates are the same. Tax rate equals tax amount divided by cost before tax. Tax rate equals 15 divided by 153. Tax rate equals, let me go off camera here and bang this through the calculator. We got this. The weird tax rate. Tax rate's this. So 0.098. I'm going to chop this off and we'll just do 1% here. So, or 9.8%. Calculate sales tax on the second item. Now we have the tax rate that's charged in this store in this particular state or country. We carry that tax rate over to the second item that was purchased. Sales tax equals cost before tax times tax rate. Each good, you're going to pay a percentage of that in tax. I'm going to use the decimal. You could use 9.8%. I like the decimal. Sales tax equals, I'm just going to do this. I'm going off camera into my calculator. And we got this. We round to 2 decimals for dollars and cents, and we get sales tax equals, hold this because this is the answer, $8. It's important to know here what I just did because your questions will round any financial amount. They're going to round to dollars and cents. Cents are 2 decimal places. When we ran this problem through, we got this. This is not rounded to 2 because the third decimal place is 5 or higher. We round up to the next cent, which is $8. In this problem, we had sales tax, we had rounding, we had percentages, and we're done. All right, we're making good progress here. Block this off. That's a note for me. Start at the top. Larger of 2 numbers is 12 more than the smaller number. If the sum of the 2 numbers is 74, find the 2 numbers. Clear variables for each number. Let L be the larger number. Let S be the, enough of this. S be the smaller number. Great. We're given 2 equations. Equation 1 says the larger number equals 12 more than the smaller number. More than means we add. And the second equation, if the sum of the 2 numbers is 74, sum means we add 74. Okay. I've got good news for you because simultaneous equations are sometimes a pain, but we've been given a gift in equation 1. Equation 1 already has L solved for. Substitute equation 1 into equation 2 for L. We're using what's called the substitution method. So if you've heard of this or haven't heard of it, there's 3 ways to solve simultaneous equations: substitution, elimination, and Kramer's rule. However, when you're given a gift like we have been, you go with substitution, and then you'll be able to solve these real quick. I'm going to take equation 2 and just paste it down here. L is S plus 12, right? So I'm going to take L and substitute S plus 12. Right. Now, real quick, I'm going off camera to grab the Math Celebrity work. Okay. And I'm going to copy and paste all the math so you could see how we solve this. All right, I just pasted it in. We want to solve for S in this equation. The first thing we do is regroup the like terms. 1s plus 1s is 2s. Our new equation's 2s plus 12 equals 74. We want to group the constants so we can isolate the S term. Cleaning up some format here. And then once we do that, we get 2s equals 62. Divide each side by 2 to isolate S. We get the smaller number, S is 31. Great. So we've solved for 1. Now what I want to do, I want to solve for L. To solve for L, we substitute in S equal to 31 into equation 1. This was equation 1, right? But we're told S equals 31, so that means L equals 31 plus 12, L equals 43. Outstanding, we've got our two numbers. So I'm going to scroll back up here. We declare our variables for the large and small numbers. We write out the givens in equation form, and then we solve. In this case, we could use substitution. We have a new equation. We simplify it, evaluate, we get one of the variables, in this case S. We then take S and substitute it back into either one of these equations to solve for L. Because L is already solved for in this one in terms of S, I used equation 1. It's faster, easier, less mistakes. We get our second number and we are done. All right. Let's keep the momentum moving here. Okay, I'm going to go back here. All right. The sum of x and 10 equals the sum of 2 times x and 12. The sum of x and 10 means we add 10 to x plus 10. Sum of 2 times x means we multiply x by 2x. Sum of 2 times x, the sum of 2 times x and 12 means we add 12 to 2x plus 12. Now we want to add both those terms. We add this to this. And I'm putting this in parentheses for a reason because we're adding the whole thing, right? Distribute the parentheses, and we get, because we're adding positives and there's no multiplier out here, we could just remove these parentheses. Group like terms. We have 1x plus 2x plus 10 plus 12, 3x plus 22. What we did here is we grouped the x terms, we grouped the constants, and we get our final answer, our algebraic expression. That's that. All right, let's take this one. Cube root of a number in 7. Because it didn't say the quantity, we're going to hit just this with the cube root. All right, and let's algebraic expressions, exponents. That's what we're doing in this one. Phrase, a number, means an arbitrary variable. Let's call it x. If you've been on the live streams before or used our site, we've covered these a bunch of times. But if you're new, I just want to cover this because this is a very important point in algebra. Whenever you see a number, you can pick a variable. You can pick A through Z. The only variables you can't use, I believe, are I and E because those are reserved. I like to pick X because it's common. Everybody knows X. You could pick Y, A, whatever. But the key is whatever you use for a number, you have to use it for the rest of the problem. You can't start with X and then, I want to use A. If you choose A, you got to use whatever you chose at the beginning. Cube root of a number means we raise x to the 1/3 power. X to the 1/3, or you can have the little square root sign with a root out with the 1/3 out front. Either way. And 7 means we add 7. We have x to the 1/3 plus 7, and we are done. Knock that one out. All right. Let's do this one for a while. But it's nice to see a finance problem on here. Okay, so this is compound interest. This is balance. All right, and it's also accumulated value. The problem reads 1,100 per month for 10 years if the account earns 2% per year. Now, if you're new to finance, you may be asking, well, what's the question? And what they're doing is they're just typing in shorthand. What they really want is the balance. If they deposit 1,100 per month in an account for 10 years and the account earns 2% per year, how much are they going to have after 10 years? And so let me just type out what I just said. What the student or parent is asking is if they deposit 1,100 per month in a savings investment account every month for 10 years and they earn 2% per year, how much will the account be worth after 10 years? Boom. Okay. Let's go over here. 1,100 per month. But the interest credits are annual. Deposits are monthly. Interest crediting is annual. What we want is to match the two based on interest crediting time, which is annual or yearly. 1,100 per month times 12 months in a year equals, I'm going to go off camera here, and 100 times 12, we got 13,200 per year in deposit. Since we matched interest crediting period with deposits, we now want to know I'm going to change this up. If they deposit 13,200 per year in a saving every year for 10 years. All right. This is key here because most of the time the deposit period should equal the interest crediting period. In this problem, it does not. That's the key. That is the trick. I got to find the calculator so I can paste this for you. I think it's compound interest. 1 second. Outstanding. 13,200, 10 years, 2%. So we got 13,200, 10 years at 2% with annual crediting. Okay. All right. And actually, I'm going to paste all this. No, I'm not going to do interest earned. I'll just do the balance because if they want interest earned, they would have asked for it. Okay. I'm going to paste this in. Here we go. We already made the adjustments. I'm deleting that part. Okay. So make sure audio's still on. Yes, it is. Good. All right, switching back. Our accumulated balance using the formula is this. A, which is our accumulated balance, equals B, our initial balance, times 1 plus I raised to the n. And then it tells you what all this is. Since we matched our deposit and interest crediting period, we can just plug in our numbers. And I got to do raised to the 10. Raised to the 10. When you plug all that in, we start with an initial balance of 13,200. We do 1.02 raised to the 10. Actually, wait. I'm sorry. This is an annuity. Oh, geez. I'm sorry. Here. Let me delete all this. I don't want to. So we've got celebrity ANNIMPV.php. Idiot. There we go. Okay. Let me unscrew this. I apologize. 13,200, 10 years, 2%. Okay. What this is it's called an annuity. An annuity is payments made at a constant period. All right. Calculate accumulated value. Here we go. The table's not pasting in right. So payment 1 plus I to the n minus 1. Okay. AV equals payment times 1 plus I raised to the n minus 1 divided by I, right? If I plug that in, for 0.02, and then raised to the 10, we got 1.02 raised to the 10 minus 1 divided by 0.02. I got to fix the formatting from my site. This divided by 0.02. Clean this up. Do AV equals 1, 2, 3, 4. This AV equals this. This. Okay. 144,536.32. All right. So what's happening here is this is an annuity. This is what's an annuity, which is a constant stream of payments with interest crediting at a certain period. So what I did is I pasted in here the annuity formula and calculator from Math Celebrity. I plugged in the numbers that we used for this problem, and what we got is at the end of 10 years, you're going to have 144,536,032 cents. So I'm going to do an annuity. That's what we do. That's it. All right, 2 more. We can go sign off for the day. Twice the square root of a number increased by 5 is 23. The phrase, and you've probably seen this now, a number means an arbitrary variable. Let's call it X. I'm going to jump over here and just see if anybody's in the chat. Okay, good. We're good. All right. The square root of a number means we raise X to the 1/2 power. I'm just going to say square root because that's how you're going to write it, or the little radical sign, which I don't have here on this page. Okay. The square, I'm going to take each piece here. This means we add 5 to square root of X. Square root of X plus 5. Twice square root means we multiply this by 2. And we have, by the way, we have to wrap this in parentheses because we're multiplying the whole term by 2. And then finally, this little piece here is 23. the phrase is 23 means we set this equal to 23, and we are done. That's that. Algebra expressions, we got an arbitrary variable. Boom. All right. Last but not least, weighted averages. All right. Oops. No, I don't want to create a thread. Clicking random buttons here. All right. At Priscilla's school, the final grade for her calculus course is weighted as follows: tests 50%, quizzes 30%, homework 20%. Priscilla has an average of 87% on her tests, 100% on her quizzes, and 20% on her homework. What is Priscilla's weighted average? Since we're already given the averages, weighted average equals average times weighting percent. In this case, weighted average equals test average times test weighting plus quiz average times quiz weighting plus homework average times homework weighting. Okay. Now that you know weighted average, plug in our numbers. Test average is what? 87% times 50% weighting plus quiz average 100% times 30% plus 20% on homework times 20% weighting. Okay, almost there. Now what we got to do is take each piece. So 87% times 50% is what? 87% times 50%. 87% times 50%. 43.5% plus 100% of 30%. So there's no reduction, which is great. I'm sorry, 100% times 30%. 30%, right? Because there's no reduction. Plus 20% of 20%. 4%. Plus 4%. Weighted average equals, now we add all these up. 34 and 43 is 77.5%. 43.5. 77.5%. This weighted average gives weights to each percent of the average. There. This was the key here. If you know this formula, you can breeze through these problems. So weighted average is just average times whatever the weighting percent is. And you'll see this in certain things, especially class, because they weight tests the heaviest, quizzes the second heaviest, and then homework the lightest. And this is the formula. So that's it.